Okay, so now let's get to the example, to the miscellaneous examples on this chapter. There is a problem here that I did try to solve it, but it seems that it's a little bit, it's a good it's a good exercise, but for whatever reason I don't get to the answer, meaning that I did try, but the problem that I have here is that I don't quite see where I'm going. So now the question over here is the variance of 20 observations is 5, right? I have 20 observations, the variance of those observations is 5. Now if each observation is multiplied by 2, find the new variance of the resulting observations. So what I think it means, or what it actually means, is that you have 20 observations, let's say x1, x2, for example, x3, all the way up to x of 20, and over here sigma of x squared is equal to 5. Now suppose that I take all of these observations and write it as 2 times x1, 2 times x2, 2 times x3, and all the way up to 2 times x of 20. I want to know what is the sigma of x squared here. That's what I want to know. So now let's see how we can solve this problem. I did try to solve the problem in 2 different ways. I couldn't because I don't know how to approach the problem. That's important. I do understand what my problem is, and that is I do not know how to go about solving this problem. And when that happens, you get confused. You don't know what to do. You don't know which step to take next, and so on and so forth. So now let's see what we have here. It says that let's let the observations be x1 to x of 20. So that's basically what we have done here. So I have taken the observations, let the observations be x1 all the way up to x of 20, and x bar be their mean, and x bar be their mean. Given that variance is equal to 5 and n is equal to 20, given that variance is equal to 5 and n is equal to 20, we know that basically sigma squared, or variance, generally it's equal to basically 1 over n, 1 over n sigma of, you can write, you can omit basically f of I here, so x of I minus x bar whole squared as I goes from 1 to n, which is equal to, which you can write as 1 over 20. This n over here is nothing but sigma f of I. And since I omitted sigma, basically f of I here, I'm assuming that the frequency of each of these observations is 1. So then sigma f of I as I goes from 1 to 20 is going to be equal to 1 times 20, which is equal to 20. So that's 1 over 20. And then basically sigma of x of I minus x bar whole squared as I goes from 1 to 20, right? So far we have no problem and we have understood everything. And or you can say that basically based on this equation, I see. Oh, that was so simple, I missed the point. Okay, so now what we have here is basically, you know that the variance here is equal to 5. Or you can say that basically, if I write basically if the variance is equal to 5, then I can write 5 is equal to 1 divided by 20 sigma x of I minus x bar all squared as I goes from 1 to 20. And that means that basically this part of the expression is equal to 5 divided by 1/20th, or basically 1 times 20, which is equal to 100. That means that sigma x of I minus x bar all squared as I goes from 1 to 20 is equal to 100. We call this equation number 1. Now if basically if each observation is multiplied by 2, and the new resulting observations are y of I, and the new resulting observations are y of I, then we have basically y of I would be equal to 2 times x of I. 2 times x of I. Or you can say that x of I is equal to 1/2 times y of I. 1/2 times y of I. And that basically means that y bar and if each observation is multiplied by 2, then originally over here our x bar is equal to sigma x of I divided by sigma f of I. Now if each observation is multiplied by 2, so then instead of x of I over here I can write y of I. I'm sorry, instead of each x of I can write 1/2 y of I. So that means that then y bar would be equal to sigma 1/2 y of I over sigma f of I, which is equal to what I was doing here is not right. Okay, so now what we said is that if each observation is multiplied by 2 and the new resulting observations are y of I, meaning that y of I is equal to 2 times x of I, then I can write x of I is equal to 1/2 y of I, right? Now, what we have basically x bar, as you know, is equal to sigma x of I over sigma f of I. So now instead of x of I can write 1/2 y of I. Let's see if we can get some sort of relationship between x of I and y of And let me see what we get here. So so then basically over here, if I write as, then x bar is going to be equal to basically sigma 1/2 y of I, 1/2 y of I over sigma f of I, which is equal to basically 1/2 times sigma 1/2 times sigma y of I over sigma f of I, which is the same thing as 1/2 times y bar. So that means that x bar is equal to 1/2 times y bar. So then basically now I know that x of I is equal to 1/2 y of I. This is one thing. And the other thing that I know is that x bar is equal to 1/2 y bar. And substituting that, if you substitute these values, these new values of x of I and y bar in equation number 1, you will get basically over here we had sigma of x of I, which is equal to 1/2 y of I. X bar is equal to 1/2 y bar whole squared as I goes from 1 to 20 is equal to 100. Is equal to 100. So sigma 1/2 times y of I minus 1/2 y bar whole squared as I goes from 1 to 20 is equal to 100. That means that basically sigma of is equal to 400. Okay, so now we need to simplify this thing. Now we have actually gotten to the right equation, which was something that I was very excited for. And now I have gotten to the right equation. Now we need to simplify it. And the way to simplify this thing is basically, but before I simplify this, let me see how they have solved this problem. So what they have done is that they have written, so it seems that if you simplify this equation, what you will get is that sigma of basically y of I minus y bar whole squared is equal to basically, as I goes from 1 to 20, is equal to 400. Is equal to 400. That's the variance of the new observations is equal to 1/20th times 400, which is equal to 20, which is equal to okay, 4 times 5 is equal to 20. Okay. Now that the rest is not that important for now, but what we need for now is we need to simplify this and get this out of here, get these 1/2s out of here. So you know that a minus b raised to the power 2 is equal to a squared plus b squared minus 2 times ab. So if I write over here I think that the right way to do that would be just this. So sigma of y is equal to 1 to 20 of basically a squared, which is equal to 1 divided by 4 y of I squared plus b squared, which would be 1 divided by 4 y bar squared, and negative 2 times a, which is 1/2 y of I and the other term would be 1/2 basically y bar is equal to so 2 and 2 you can cancel out, and you will get negative 1 divided by 2 y of I y bar, y of 2 y of I y bar. So I can write this as negative 1/2 times y of I y bar, and not raised to the second power anymore, and that is equal to 100. Now your goal is to make this to write this in the form your goal is to write this equation in the form sigma y of I minus y bar raised to the second power, for example, is equal to times some constant, for example, some a is equal to, for example, 100. So the way that you can do that, so you see that it's a minus b whole squared is equal to a squared plus b squared minus 2ab. So what that means is that I can take so I have to take a 2 over here. If I take a 1/4 out, if I take a 1/4 out from this part, sigma of I is equal to 1 to sigma of I is equal to 1 to 20, and take a 1/4 out and write over here y of I squared plus y bar squared, and then minus basically 1/2 divided by 1/4 is equal to 1/2 times 4, which is equal to 2. So it just works out the way that it should. So 2 times y of I y bar is equal to 100. And of course you can write this as y of I basically minus y bar whole squared. So you can write this as 1/4 times sigma of y of I minus y bar whole squared is equal to 100, which means as I goes from 1 to 20, which means that sigma of y of I minus y bar whole squared is equal to 100th divided by 1/4. 100th divided by 1/4, which is equal to 100th times 4, which is equal to oh, this is not 100th, but this is just 100. Sorry. So this is 100. So that would be basically, you would have 100 over here. So 100 divided by 1/4 would be 100 divided by 1/4, so would be 100 times 4, which is equal to 400. So you get a 400 here. And so that's exactly what they have actually found in the book here. So you can write this equation as sigma of y of I minus y bar whole squared as I goes from 1 to 20 is equal to 400. And then what that means is that And then what that means is that so over here what we said was that so y of I over here is equal to what? 2 times x of I. So so now we have this in terms of, now we have sigma of y of I minus y bar whole squared is equal to 400, which means that, and if I somehow compare this to what we had here, if I compare this to what I had over here, which is basically sigma of, we said that sigma of x of I minus x bar, we said that sigma of x of I minus x bar whole squared as I goes from 1 to 20 is equal to 100. And also we said that sigma of x of I minus x bar, 1/20th of that is equal to 5, which is basically the same thing. So what that means is that sigma of so you can say that sigma of y of I minus y bar is equal to 4 times basically sigma of x of I minus x bar whole squared. So you can say that sigma of y of I minus y bar whole squared as I goes from 1 to 20 is equal to 4 times sigma of x of I minus x bar whole squared as I is equal to 1 to 20. And now how do I compare? So we said that the variance of these 20, let me just compare to this. So we said that this value was equal to 5. So we said that 1/20th of, let me compare it this way. This is not going to help us. So we said that 1/20th times sigma of x of I minus x bar whole squared as I goes from 1 to 20 is equal to 5. So what that means is that now I have to somehow put this 1/20th over here so I can compare this part over here, right? So if I divide basically this side of this equation by 20, what I will get is basically 1/20th sigma of basically y of I minus y bar whole squared as I goes from 1 to 20 is equal to 400 divided by 20, which is equal to basically 20, right? 40 divided by 2 is equal to 20. And so 1/20th times sigma of y of I minus y bar whole squared as I goes from 1 to 20 is equal to 20, and 1/20th times basically sigma of x of I minus x bar whole squared as I goes from 1 to 20 is equal to 5. That means that this is 4 times. That means that the new variance, let's call it sigma 2 squared, is equal to 4 times sigma 1 squared. Okay. Now, as another example, let's see what we have left here. And there is a note over here as well, and of course you can see that this 2, you can write it as 2 raised to the power 2. So it says that the reader may note that if each observation is multiplied by constant k, the variance of the resulting observations becomes k squared times the original variance. So this is important. It says that if each observation is multiplied by, and we showed basically just one case over here, but then you would have to prove it if you want to know how that works. But if each observation is multiplied by a constant k, the variance of the resulting observations becomes k squared times the original variance, which is something, of course, useful when you get into higher mathematics. You get to use all of these things in solving different types of problems. Okay, so now question number 17 is the mean of 5 observations is 4.4. So you have your n is equal to 5 and your x bar is equal to 4.4. So the mean of your observations is 4.4 and their variance is 8.24, and sigma squared is equal to 8.24. If 3 of the observations are 1, 2, and 6, 3 of the observations are 1, 2, and 6, find the other 2 observations. That's also a good question. The other 2 observations. Okay, so now in order to solve this problem, well, I did try to solve it, but I got into a couple of problems And let's see, let's solve it again. So basically the situation over here is that you know your n is equal to 5, the number of observations. The mean of your data is 4.4, the mean of your observations is 4.4, and the variance of your observations is 8.24. And you know 3 of your observations, you want to find the other 2 observations. So let's see how we can solve that problem. Okay, so now one thing that you can do is that you know that the mean of your observations is 4.4. So you know that let the 2 observations, for example, be x and y. You can basically let the 2 observations be x and y. And the series therefore becomes basically 1, 2, 6, x and y. Now the mean of your observations or your x bar is equal to 4.4, which is equal to 1 plus 2 plus 6 plus x plus y divided by 5, which is equal to basically, so that is the same thing as, so that means that basically 4.4 is equal to this fraction. And that means that 4.4 is equal to basically 6 plus is equal to 9 plus x plus y divided by 5. Now 5 times 4.4 is equal to 5 times 4 is equal to 22. 5 times 22, 1 decimal point, is equal to 9 plus x plus y. That means that x plus y is equal to 22 minus 9, which is equal to 13. X plus y is equal to 13. So now if I call this equation number 1, and then I know that the variance of the data, I know that my variance, which is equal to sigma squared, is equal to 8.24, which is equal to 1 over n sigma of basically x of I minus x bar whole squared as I goes from 1 to 5. So that means that 8.24 is equal to 1 over 5 times x of I minus x bar. So you know that your x bar is equal to 4.4. So then x of I are basically all of these x of I. So that's basically the same thing as 1 minus 4.4 whole squared plus 2 minus, for example, 4.4 whole squared plus 6 minus 4.4 whole squared plus x minus 4.4 whole squared plus y minus 4.4 whole squared. Okay, so now I did basically do the rest of this problem, but I got into a problem, so I need to come back over here and solve the problem again. And the answer was actually wrong, so okay, so then we need to do now is that basically solve this equation for x and y. And the other things that we know about x and y is that x plus y is equal to 13. So now let's see what we get. So 8.24. So 8.24 is equal to 1/5 times, basically, for example, 1 minus 4.4, which is equal to negative 3.4. Negative 3.4. And let me put my calculator here, so I don't have to. So 1 minus 4.4 is equal to negative 3.4, right? So negative 3.4 squared. So actually I have to write this as negative 3.4 squared. And then I have 2 minus 4.4 squared, which is equal to basically 2.4, negative 2.4 squared, which is negative 2.4 squared. So 2 minus 4.4 is equal to negative 2.4 squared. So that's plus negative 2.4 squared. And then you have 6 minus 4.4 is equal to okay, so that is 6 minus 4.4 is equal to 5, 10, so 10, 6, and then 1.6. So that's 1.6 squared. 1.6 squared. And then you have basically x minus 4.4 squared. Now, what you can do with this part is x minus 4.4 squared is that you can, of course, expand it, write it as, for example, x squared plus 4.4 squared minus 2 times 4.4 times x, which is 8.8 times x, plus again y squared plus 4.4 squared minus 8.8 times y. So that is all that we have here. Now, you need to be careful with calculation because you make mistakes. You do make mistakes while you're doing the calculation. That's what I do, at least during the past few days. So you need to be careful there. So for example, 34 times 34. And you have 2 decimal places there, negative raised to the second power is positive. So 4 times 4 is equal to 16, 1. 4 times 3 is equal to 12, 13. 0, 3 times 4 is equal to 12, 1, 9, and 10. So you have 6, 5, 1, 1. And 2 decimal places is 11.56. 11.56. Next you have 2.4 squared. So 24 times 24. 2 decimal places, 16, 1. 8, 9, 0. 2 times 4 is equal to 8. 2 times 2 is equal to 4. They have 6, 17, and 5. 2 decimal places, 5.76. 5.76. Now 1.6 squared is 16 times 16, 2 decimal places, 6 times is equal to 36 degrees, 6 and 9, 0, and 1 times 16 is equal to 16, 6, 9 plus 6 is equal to 15, and 256, 2.56. 2.56. And over here you have 4.4 squared. So 4.4 squared is equal to, let me write it as 4.44 times 44. 44 times 44, 2 decimal places, 16, 1, 16, 17, 0, and again 4 times 44 is equal to 176, and then you have 6, 13, 1, and that's a 9, that's a 1, so you have 2 decimal places, 19.36. Now 19.36, you have 2 of these. So 19.36 times 2 is equal to 2 times 6 is equal to 12, 1. 2 times 6 is equal to 6, 7. 2 times 9 is equal to 18, 1. 2 times 1 is equal to 2, plus is equal to plus 1 is equal to 3. 2 decimal places, 38.72. 38.72. So now this is taken care of, 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 and this is taken care of. And so I can write basically x squared plus y squared. So these two are taken care of as well. And then I can write negative 8.8 plus times negative 8.8 times x plus y. And multiply this by 1/5 is equal to 8.24. Okay, so now x plus y is equal to 13. So instead of this, I can write 13. And over here, I can multiply by, let me first simplify this part over here. So if I write 8.8 times 13, so 8.8 times 13 with 1 decimal point, I'll get 3 times 8 is equal to 24, 2. 3 times 8 is equal to 24, 26, 0, and 88. So you have 4, 8 plus 6 is equal to 14, 1, and that's an 11. 1 decimal point, that's 114.4. So over here I have negative, so instead of this I can write 114.4. 114.4. And then if I add all of these numbers together, I'll get 11.56 and 5.76 and 2.56 and 38.72, 38.72, and then over here I have negative 114.4. So let's add these together. We'll get basically 3 times 6 is equal to 18, plus 2 is equal to 22. 2, that's a 9, 9 plus 9, that's a 9, and then here you have 17. 9 plus 17 is equal to 26. You have a 2 here. So that's a 10, 11, 11 plus 7 is equal to 18, 1, and 3 plus 2 is equal to 5. That's 58.60. Now 58.60 is positive, and this is a negative number. So I write it as 114.4, and put a negative sign here, and 58.6. Now I have to subtract and then make the number a negative number, or basically algebraic opposite. So I make this a 0, a 10, 13, and 14. So that's an 8. That's a 5. 13 minus 8 is equal to 13 minus 8 is equal to 5. Okay. 10 minus 5 is equal to 5, so that's negative 55.8. Negative 55.8. So the whole thing over here becomes, this becomes 1/5 times x squared plus y squared minus 55.8. And over here I have 8.24. Now, what we have here, basically we want to get rid of this 5 here. So I multiply both sides by a 5. I get 8.824. 824 times a 5, 2 decimal points. 5 times 4 is equal to 22. 5 times 2 is equal to 10, 12, 1. 5 times 8 is equal to 40, 41, and you have 2 decimal points, 41.2. So you get 41.2 is equal to, this becomes a 1, and then x squared plus y squared minus 55.8. If you don't pay attention, you will make mistakes, as I did, and then you have to come back as I did. Well, now that means that x squared plus y squared is equal to 41.2 plus 55.8, which is the same thing as 0, 1. That's 7, and that's a 97. So that is x squared plus y squared to square 97, and basically we said that x plus y is equal to 13. Now, the way that you can solve these equations is that there is a trick here. You can take this equation and raise both sides to the second power, meaning that 13 squared. So that means that x squared plus y squared plus 2 times xy is equal to 169. Or x squared, now x squared plus y squared is equal to 97 here from this equation. That is 97 plus 2 times xy is equal to 169. Which means that 2xy is equal to 169 minus 97. Minus 97. Which is equal to 2. And this is 0, 16. 16 minus 9 is equal to 7. 7 plus 9 is equal to 16. Okay. So that is a 72. Okay. Now, that means that this is 36. That means that xy is equal to 36. Now I know that x plus y is equal to 13. And xy is equal to 36. So I can, for example, write here x is equal to 13 minus y. And so over here I can write, for example, 13 minus y times y is equal to, for example, 36. Or 13y minus y squared is equal to 36. Or take everything to the other side, so y squared minus 13y plus 36 is equal to 0. And then solve this equation to solve for y. So, to solve this equation, what you can do is that, so you know that 36 is the same thing as 2 times 18. Or 2 times 9, so that's 4 times 9. 4 and 4, and you can see that, so you can write 36 as 4 times 9. Now 4 plus 9 is equal to 13, as you can see here. And negative 4, negative 9 is equal to negative 13. Negative 4 times negative 9 is equal to positive 36, which as you can see over here. So the numbers that I need are -4 and -9. The numbers that you pick here, the sum of those two numbers has to be this number here, and the product of those two numbers has to be this number here. Of course, provided that your coefficient here is 1. So then I can rewrite this equation as y squared minus 4y minus 9y plus 36 is equal to 0. And then I can take from, for example, from these two terms, take a y out, y minus 4, -9 times y minus 4. And from these two terms, taking -9 out, y minus 4 is equal to 0. That means that y minus 9 times y minus 4 is equal to 0. That means that y is equal to 9, or y is equal to positive 4, 9 or 4. Now, either case, oh, there was a better way to actually do this, but well, we missed that. So now what you can do is that you know that x let's see. Well, this is a very tricky question. Okay, so either y is equal to 9 or y is equal to 4. Now, if y is equal to 9, then over here we said that basically y plus x is equal to 13. So if y is equal to 9, then x is equal to 4. Well, it works out basically, but it's a tricky question. So if y is equal to 9, then x is equal to 4, of course, because 4 plus 9 is equal to 13. And if y is equal to 4, then x is equal to 9. And basically the remaining observations are basically 4 and 9. So the remaining observations are 4 and 9. That means that you can write your series as basically 1, 2, 6, 4, and 9. You can write it as 1, 2, 6, 4, and 9, or write it as 1, basically 2, 4, 6, and 9. So that is basically the observations that you had. But of course, there is some other way to get this, meaning that from here, let me show you what we had over here, because somewhere down here I did, of course, what I did was not wrong, but I could have done it in a different way, probably even better. So over here we said that basically 2xy is equal to 72. 2xy is equal to 72, right? From here, we said that 2 times, over here, 2 times xy is equal to 72. And, well, let's not worry about that one. It's really not that important anymore, but you can put all of these equations together to get different equations. Now, the next question that we have is question number 18. And we have question number 19 as well, and then we are done with this part. But then let's get to question number 18 in the next video. I'll see you in the next video. Thank you.